Hello, Internet, and welcome to the first episode of Paul's Shop. So, what we're going to be covering today is a heater system for lithium iron phosphate batteries. If you see down here, charge temperature 0 Celsius to plus 45. 0 is freezing, 32 degrees Fahrenheit. So, we got to keep these batteries at 32 degrees Fahrenheit or better to allow them to charge. If you don't do that, what happens is if you try and charge them below 0, they'll build up fingers or whatnot between the plates, and then your batteries will get destroyed. So in an unheated environment like my garage, we have to find a way to heat them. So what we're going to do is show you what I did to heat these batteries. You're going to need a couple parts. This is a DC to DC converter, and they tell you not to hook these up to solar panels, probably because people tried to use them as chargers, and it's only capable of a 120 watt output. So if you tried to run that into a battery, you would destroy this DC to DC converter. And the next thing we need is a thermostat. This is a thermostat off of Amazon. It was less than 20 bucks, and it will handle 14 amps. So since our DC to DC converter only puts out 10 amps, the relay on this device will handle that no problem. Then we come down and we have a terminal strip for all the connections. And then we're using 4 of these silicone heating pads, which can also be gotten off Amazon. Now, the thing about it is, these heating pads get really, really hot. And they're capable of going up to about 200 degrees Celsius, which is kind of close to the melt of the plastic on this. So what I did is I sandwiched these heaters between 2 aluminum pads so they dissipate the heat. I have one set of pads that goes in here in between the batteries. I have one set of pads underneath, and I have a set of pads above. The thermostat for the thermostat switch is just basically taped inside here on one side of the battery, and I have the whole thing covered in a blanket. Then an auxiliary piece is a relay, the solid state relay that goes from the solar panels to the charge controllers. And basically the reason you need this is because if you're heating the batteries and they're not hot enough to be charged, then you want to cut off the power coming in. You don't want them to even try and charge. So what we do is we disconnect the charge controller. That way we're not charging the batteries until the batteries get up to the proper heat. Okay, so let's talk about how this system actually functions. Right here we have the solar panels, and I have 4 solar panels in parallel. So they put out approximately 40 volts. So you got 40 volts that comes in here and comes down to a fuse. There's a 10 amp fuse here in case something happens. That 40 volts goes into this DC to DC converter and comes out as 12 volts. That 12 volts comes over and feeds our thermostat, our electronic thermostat, and it also comes over to a switch portion of that thermostat, which is one side of the relay. The other side comes out and feeds our heaters. So when the thermostat kicks on, our heaters kick on. And basically, like I said, this is 120 watts. These are 25 watt pads. So I'm only pulling 75 watts of the possible 120. Plus I'm driving the thermostat, which is very minimal. And I'm driving the solid state relay. Okay, so when I have 12 volts coming out of this device, it's feeding our heaters, like I said, but it's also coming over here, and normally it would be turning on the solid state relay. However, I had a problem. The solid state relay is wired backwards. But what I mean by that is it needs a positive voltage right here to light this LED and turn on, allow current flow through the outside of the relay to the charge controller. I need this off when I'm trying to heat the battery. So what I did is made a simple transistor circuit with a 2N2222 transistor, which is just a basic NPN transistor. So when that positive voltage comes over here, it turns this transistor on. When this transistor comes on, it actually applies a short to the relay, which turns it off. So then when the thermostat kicks off, this 12 volts is no longer here and being present, and the 12 volts comes down through this resistor, this 1K resistor, comes through this network and turns the relay back on. So let's watch this in operation. This thermostat is very easy to operate. Basically, all you have to do is hit the set button here, and you can see you can change this from heating or cooling. We want heating. Over here, we have it set right now to 6 degrees Celsius, and it's a 1 degree change. So it can go down to 5 degrees or up to 7 degrees to turn off. So if I were to reset that, I'm showing basically 16.2 degrees Celsius right now because it's a little bit warm. But if I want to turn this on just to demonstrate the system, I'm going to take this and I'm going to, we'll set it up to about 18 or 19. We'll set it at 18.1, see if that works. Once it stops flashing, okay, we see that this LED down here is turned on. So that means that we are now outputting 12 volts to the heaters. If we take a look up here, we can see that our relay is off. So the 12 volts actually came up, turned that transistor on, and turned our relay off. And if we look at our charge controller, we can see that we're outputting 0 volts and 0 amps. So we've effectively cut that off while the heaters are on. So now we're going to go back and reprogram this back to where it was. We want heat. We're going to take that 18.1 and we're going to take it back to 6 degrees Celsius because that's 2 degrees above what the batteries need. And we give ourselves a bit of leeway with that 1 degree difference. Leave that 1 degree difference. Let that flashing stop. We can see that our LED for the relay activation is turned off at this point. We can go up here and see that our relay is turned on. We're allowing power through. And we can see our charge controller is now pushing 38.4 volts and 6 amps. So we know that the system is working. It does exactly what it has to do. And the interesting thing is it's self-protected because people would say, well, what happens if this fuse blows? Well, if the fuse blows, you won't have 12 volts. There'll be no 12 volts up to the relay, so the relay will kick off, so you're protected there too. So the system, even though the system looks complicated, it's not really. In this transistor circuit, you don't need much to make it. You need basically an NPN transistor. You need a 1K ohm resistor, which is a ½ watt for the collector current. And you need an 82K ohm resistor, which will protect that base and keep that junction there from burning up. So fairly simple system. You really don't need to know electronics to do it. I just, if you see here, I just breadboarded it on a cheap piece of breadboard. You can see the transistor right here, your collector resistor, and your base resistor, and your ground. And I just soldered some terminals onto the edge here for activating the relay. So if you can do some basic simple soldering, then you can have a really nice heater for your system. Looks complicated, but it's not really. And that's all we have for this video. Thanks for stopping by. Please like and subscribe. Hopefully I'll be able to build a channel on just instructing people how to do stuff. If you use it at your own peril, your own discord. I'm not going to be responsible for what you do, but I can tell you this system's been out here for a month and it works great. In the next video, we're going to discuss what to do with these batteries, because the first battery, I have another system that I got a battery from this company, and it was great. It absolutely works. It absolutely cycles well. I think this poor guy had these batteries made and they were stuck and they're terrible. So what we're going to do is take two of these batteries apart and make one 24-volt battery. And then if that works successfully, we're going to take the other two batteries and eventually we'll have a 200 amp hour system for out here.